Hello. Um, I'm going to sort of finish up. This is the third part of the video, and we're going to do examples. So just want to summarize where we've been. This is what a polynomial looks like. Its degree is the highest coefficient. I'm sorry, the highest exponent. So n, this is the leading coefficient. Right here. Okay. Now, what I want to talk about today through this example is that the number of zeros for this is at most n. And remember, it's really hard to find the zeros of a function unless if we get lucky. Like here, we're lucky because somebody gave it to us. We could factor this, and I can go through that. Or we can factor it. Now, what I'm going to show you is because the number of zeros is at most n, the number of turning points must be one less than the number of zeros. So one less than n, okay, number of possible zeros. So I want to look at this example right here. That's what I'm going to start with. So if you want to try that, hit pause, and then I'm going to go do it on the next page. Okay, so maybe you tried this. So I'm going to look at a couple of things. We know that this has 1, 2, 3, 4. Its degree is 4. And remember, we saw that this before in the last page. I might as well write that down here. Is that this is equal to 4x to the fourth, 40x squared plus 36. Okay. Now, so that means it's going to be, sorry, our an, which is leading coefficient, is 3 greater than 0. Sorry, that should be a, how did I get a 4 there? Yikes. Oh, this must be a 4. Sorry. Okay, that looks much better to me. Okay. So our, sorry, I just miscopied that. I should have had it 4 in the last one. I just didn't see my error. So over here I wrote a 3, and that should have been a 4, and I apologize for that. Okay. Okay. So we know that this graph is going to, since it's even and an is greater than 0, the graph is going to start high and end high. And our guess is it's something like this, maybe. Okay. So that's our first guess. So now we know that there's zeros, so I'm going to mark the zeros on the graph. So if I get x is equal to minus 3, from here is 1, 0. Minus 1 is another one. So the graph is going to go through these points. It's going to have this shape. 1 is another 0. And then 3 is 1 over here. And then if I plug in f of 0, I'm going to get 0, 4 times 0, minus 40 times 0 plus 36. So I'm going to have a y-intercept of 0, 36, and we'll come back to that. So I know the graph starts up high, so it's going to come down like this, go up, come down, go like this, and go like that. Okay. Notice it has to go through each of the zeros. That's what it means to be a 0. And to get from here to here, it's going to go down and turn around again. So it's going to have a turning point. That's what I mean. That's a min. That's one of the places it turns around. There's a turning point somewhere around here, it looks like. That looks like a max. And I'm guessing, but I'm not certain, that that max is going to be the y-intercept. That's just a guess. That's because the roots are evenly spaced. I'm just guessing that that means that the high point is going to be between these two roots. That's just a guess. So then the graph goes to 1, it has to go to 3, it's got to turn around again, and then at that point, it just starts going off towards infinity. So that's what I think the graph is going to look like. Okay, I hope that makes some sense. Now, so basically, if we had to graph this, that's the best we can do. Now, I'm going to go a little bit further and just pretend that we were given this, and it said, and the question was, graph this function. Okay, well, we can so let's say we have to graph and find the zeros. If I ask you to find the zeros, it means that you can do that without doing, you can do that probably by factoring. Okay, so the first thing I'm going to do to factor is factor out my common power of 4. And then I'm going to fool around, sort of guess and take a couple of things, and I'm going to factor. To get that x fourth, I'm guessing I have to multiply x squared times x squared. And then I have to get a 9 over here. So I'm going to guess that one factor is 1 and one factor is 9. If I do the check, x squared, x to the fourth, x squared minus 9, sorry, x squared times minus 9, x squared times minus 1, that's minus 10x squared, and then minus 1 times 9 is that. So if I FOIL it out, that looks like it gets it out. So this is one where I got lucky because I could factor it easily. Again, generally, if you just take a random fourth degree polynomial, it's going to be, you're probably not going to get that lucky. Okay, so that's one example right there. Okay. Now, here's another example that I have that I want to do. And actually, before I do an example, I think I want to summarize kind of where we are and then let you do a couple of examples. Okay, so here's our summary. And we're going to, this is for graphing. It's a qualitative graph, meaning we don't want we can't find all the details. We just want the general shape. Okay. So if n is even and an is greater than 0, it's going to be like that W shape. It's going to start high, come down, and go back up and high again. If n is even and an is negative, it's going to be kind of that opposite shape. And it could have more humps. It could have, if the degree is 20, it could have 19 humps. Okay. If n is odd and an is greater than 0, it's going to start low and go high. And if n is odd and an is less than 0, it's going to start high and work its way back low. Okay. The number of zeros is going to be, which is the x-intercepts, is going to be at most the degree. We may not have any. We've seen examples of that. The number of turning points is going to be at most n minus 1. So I think of it as happening between the zeros. And we have a y-intercept just plugging in x equals 0. And we'll use this info to graph. And our goal in graphing is just it's a pictorial way to understand the function. So maybe I'll go over that when I go through these examples. So I'm going to give you two examples. I'm going to give you x cubed minus 1 to graph that. And I'm going to say find the zeros. And again, we can factor that, as you'll see when you try it. And my next one is here. And don't find the zeros. I'm just going to warn you, you can't factor. Or I couldn't factor. Maybe you can. Okay. So anyway, I'm going to do these separately. And if you want to try them on your own and come back, I suggest you do that. Okay. So I'll give you a second to pause and come back, and then I'll start. Okay. So I need to graph this. So I know that my degree, which is my n, is 3, which is odd. A3, the leading coefficient, is 1, which is greater than 0. So I know it's going to start low and end high. So that's one of the things I know. So I'm going to say at most 3 zeros. Hopefully I can find those. And at most 2 turning points, or I call them humps, because it's just simpler. Okay, so I know a few things. Okay, so what I'm going to do is try to find the 0. Oh, and then I want to find the y-intercept. That's going to be p of 0, and that's going to be 0 cubed minus 0 to the first, which is 0. So the y-intercept is the origin. Okay. So I'm going to look at this and see if I can factor it. So for the zeros, I'm going to factor x cubed minus 1. I'm sorry, x cubed minus x. And that's going to be factor out my x. I get x squared minus 1. And I can factor x squared minus 1 into x minus 1, x plus 1. So my zeros, our x-intercepts, are going to be x equal 1, 0, minus 1. So we're ready to go. So I'm going to mark the zeros, minus 1, 0, and 1. The graph starts low and ends up here. So my guess is it's going to go through -1, turn around, come back through 0, turn around and go up like that. That's my guess. And we can check this out with Desmos and you'll see that, yeah, that's the right graph. Maybe a little bit prettier. Okay. So again, sorry, let me go back to this again, just to review what we did. We looked at the degree and the leading coefficient. That told us the basic shape of the graph. We saw that there's at least 3 zeros. We were lucky enough to find them. We found the y-intercept. It's all marked right here. And so we made a guess of what the graph looked like. Without all the details, we don't know what points these are. That's a calculus question. But here's what this tells us, just a few things. If we look at the graph, that tells us that as x gets really negative, the function goes to -infinity. So again, that's called, I'm just giving you a preview, that's called the limit. The limit is what happens when x gets really, really negative. Here we have the opposite. The limit as x goes to infinity of f of x is infinity. This graph keeps going up. And we see that we have a minimum, a max here, a minimum here. We know the max is between -1 and 0. And the min is between 0 and 1. Again, then we look at the picture, we get a sense of what the graph does. Okay, sorry to throw this limit stuff on you, but this is calculus language. I'm not going to go into it in this class, but what this means when you see something like the limit as x goes to -infinity is -infinity, it means the graph goes down, starts really low. If the limit of x goes to infinity is positive, it means the graph keeps rising. Okay. So the last example is here, and notice I say don't factor. You can't factor, or at least I can't. So I want to see what we can get out of this. Again, try it on your own. I'm going to pause for a couple seconds and then just come back. Okay. We know that n is even and a4 is greater than 2. So since this tells us that the graph is going to start high and end high. That's 4 degrees, so we're thinking maybe it does something like this. We're not sure. Okay, that's my guess. Okay, so that's one important thing. We find the y-intercept by plugging in 0, and we get 2. So the y-intercept is equal to 0, 2. Okay. So again, we really don't know much. We really don't have much to go on. Somehow the graph comes down to here, and then we know that since n is even, it's going to start high and it's going to end high, and it's somehow going to come down through here. And so I'm just going to guess. Again, this is really limited. I'm going to guess the graph looks something like this. That's my guess. Okay, and that's a good guess. We'll see if it's right or not. I don't know, but that's just my guess. So what I'm going to do is I graph this on Desmos, so I'm going to go look at it now. And here's a graph of it. We'll share the screen. And you see that I wasn't very close. This wasn't a really good picture of the graph. So I'm going to do it. I don't think you can see it because of the screen share, but I'll do a better picture. But again, this isn't wrong. I would not mark that wrong because we just didn't know the answer. Okay. Okay, so I'm going to stop the share and we'll go back and look at the graph and that'll be it. So here was my guess. Here's Desmos, not too far off, pretty close. But again, I needed the Desmos to get the details. So this is my sketch of this graph. Now graphing, I'll just close by a couple of words about this, is that graphing is hard and you really need calculus. So we need calculus to find the maxes and mins. Yeah, I'm just going to keep it at that. And we're not ready to do that in this class, so we can't really provide a great graph. The best we can do is like something like that. Okay, well, that's it. Well, thank you. Yeah, bye-bye.